Okay, one more, elementary educators, one more. Let's look at how to make an angle bisector. And by that, I mean the following. Let's look at, we've got a ray, we've got another ray, and we're looking to bisect this angle. We want to bisect this, we want to make two angles inside of there that are congruent. How do we do it? Using our friend, the compass. Well, this is actually pretty straightforward. We're going to make a swoopy, and then that swoopy is going to give us two special places. And those special places are going to be places that we're going to put our compass point. We're just going to make swoopies in the middle of nowhere. We're going to make swoopies in the middle of nowhere. Well, this is a very special place. And it's so special, in fact, that the ray that goes through there creates two congruent angles. This congruent to that. Why? Well, that's an excellent question. That's an excellent question. You got this segment and this segment, and what do we know? Well, we know that we didn't move our compass width. We didn't change the width of the compass when making these points right here. So this is congruent to that. They're on the big swoopy. And we didn't change the compass width, so this is also congruent to, they're all congruent. They're all congruent. But more importantly, this side is shared between these two triangles here, triangle RHO and triangle RMO. So triangle RHO is congruent to triangle RMO by side, side, they share a side, which means that this little piece is congruent to this little piece. So angle ORH is congruent to angle ORM, and that means that this ray that we drew is in fact an angle bisector. Well, that's curious. That's really curious. Let's do it again. Let's take a random triangle. Say random, let's make it more random. Let's make a random triangle. And let's do angle bisectors. Just so you can see what angle bisectors do, let's make them red and blue and green. There's red, so we make the big swoopy, and that gives us the two special places, and we swoopy in the middle, and we swoopy in the middle, swoop, 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 all with the same width. And so you get this angle bisector like so. And then we'll change the color and we'll come up here and we'll do the same game again. We pick some distance, it doesn't matter. We make a swoopy, doesn't matter. And so we come down to here and we say, all right, we're not moving the compass width, we swoopy. We're not moving the compass width because we need equilateral things. And then this angle bisector, like so. So now you're already thinking, I'll bet that point's pretty special, and it is. And it is. So let's confirm that this happens also with the third angle bisector. So we make a swoopy, and then that gives us two special places, and we swoopy in the middle, and we swoopy in the middle. Oh, that was bad. Luckily, I can undo. And then this angle bisector goes through that point also. I kind of turned in the middle there. That's probably terrible. That's much better. So this special place where the three angle bisectors come together is called an incenter. The incenter is the center of a circle that ever so gently kisses all three sides of the triangle. It ever so gently kisses all three sides of that triangle, just like so. This is called the incircle, and the in-center is the center of that circle, which is a very interesting finding, to say the very least. Why? Why does that hold? Well, the key comes from what we know about angle bisectors. We know that every point on an angle, but every point on this green angle bisector is just as far from that side as it is from that side. And that's kind of what a bisector of an angle is expected to do. We know that every point on this blue angle bisector is just as far from this side as they are from this side. And we know that every point on this red angle bisector is just as far from this side as it is from this side. And so what do we see? We see that this is a radius of the circle, this is a radius of the circle, this is a radius of the circle. They have to be all the same. And once you have three radii, you got what you need. Boom, there's the circle, and we're done. So it's a very interesting way to use the angle bisector construction, which is really just a rhombus, to get ourselves a very interesting point of literally any triangle you can draw. Cool. All right. I hope this has been an interesting discussion. We'll see you in class and look forward to it.